It's doing the whole page. So we'll do the whole page. Okay, so types of systems of equations. So back in Math 10, we did linear systems, and we did talk about doing a little bit, I think we did a little bit of quadratic linear, but not two quadratics together. Same process. You can use elimination, but kind of depends. You would only eliminate y, okay? The dependent variable. Substitution is probably the more common method. In any case, remember, a system of equations is a set of two or more equations with the same set of variables. In this course, we will be solving systems of two equations in two variables. Solutions to a system of two equations in two variables are all the ordered pairs that satisfy both equations. Okay, so remember when it's a linear system, you just get one ordered pair. Okay, now you might have two. You might just have one, and you might have none. Okay, if they don't intersect. So graphically, the solutions to a system of two equations in two variables are all the intersection points of the two graphs. If we were to graph them. In 10C, you studied linear. 20-1, we also studied linear quadratic. And quadratic. That's what we're doing today. Okay, so linear system, linear, you could have two parallel lines. Okay, so these will have no points of intersection, so no solution to that. They're the same distance apart all the way. Intersecting lines, okay, they have one solution. An x value and a y value, but that's considered one solution. Okay, their slopes are different. Here, coincident lines, I actually sometimes call them parallel and coincident lines. They are exactly the same equation. Maybe one is not expressed in lowest terms. So in this case, though, they have infinitely many solutions. Okay, and you would just write out the equation, one of the equations of the line. They'd be their scalar multiples of each other, right? Okay, so here, the one solution is a point. The solution here for coincident lines is a line. Okay. So, to summarize, we should have had this afterwards, but you could have one solution, no solutions, or infinitely many solutions. Okay, so that's a review from Math 10. Then, linear quadratic. So now that we know all about quadratics, makes it easier to think about what's happening. Here are the three cases. So a parabola with a line that doesn't touch it has no solution. Okay? So you could be given, for example, those kind of questions that we ask on a test. If you know the vertex of a parabola and what direction it's opening, and then we give you but we don't give you the equation, right? So you don't know the stretch factor, for example. Give you a line, can you tell if it's going to intersect? So basically, you can sometimes analyze that without knowing everything about the equation of each of them. All right, but if you're given them, you could graph them. We're going to do it algebraically because we will ask you to do some algebraically. Here, this is intersecting so this is one solution, and it's a point. And then two solutions, and they're points, 2 points. So remember ordered pairs you use. If it's an application question, then you write it out with whatever the definition of is for those variables. So no solution, one solution, or two solutions. For a linear quadratic, there'll never be infinitely many solutions. They're different shapes. Okay. Then quadratic, quadratic. So now we have a few different cases. No solutions here. Okay. And that would be, basically they would have to be opening up or down. One up and one down. Okay, this one has one solution, so it's a point. Two solutions, so 2 points. And then here, infinitely many. And this is solution is one of those parabolas. Because maybe it's one shown in standard form and one in vertex form. Just different forms. When you graph them, you get the same thing. Okay. So, I'm going to practice. Okay, so you can solve them graphically, algebraically, by substitution or elimination, just like back in Math 10. Okay, so here we go. So you get some of your own paper. So solving algebraically, elimination or substitution. If you try to eliminate, that's totally fine, but you're not going to try to eliminate the x term. Because if you do that, you're still going to be left with y and x squared. Okay? So the only way you eliminate, if it's a linear quadratic or a quadratic quadratic, is to eliminate the y. And so when you do that, if you would do it right now, eliminate, that would be 0 on the left, and then you would subtract this from the expression above. Or you can use substitution by replacing this y with 2x minus 7. Either way is fine. We're never going to ask you to do one way over another, except for if you were asked graphically, right? Okay, and then you can solve that one by factoring. Are we done? We're not done. Okay, so those are just x values. So to solve a system, you need the y values. So you need the y for each x. So this tells me here that there are 2 points of intersection. Okay, because there's 2 different x values. So now when x equals 2, what's y? I would put it back into their linear because that's just faster, right? Okay, so 2 points of intersection, and then I would summarize it. So my solution sets. Okay. Particularly if you didn't show it as an ordered pair, you've got to show it at the end. Okay, so summarize your work at the end. You don't technically have to show it as an ordered pair, but if you don't, then I better see it summarized as x equals 2, y equals 3 together, negative 3 together. And so why not just make it easier, put it in as an ordered pair. Okay, take a look at the next one. Quadratic, quadratic. So again, if you use elimination, eliminate the y's. If you use substitution, then you're really taking either this expression and putting it for this y or vice versa. So by substitution, it would really look like each equation on each side. So you can see why elimination is actually easier. Now saying that, sometimes when you use elimination, some students forget to change the sign. Because when you're eliminating, in this case, you're subtracting the equations. So you have to change these signs when you subtract. So in any case, so if you brought everything over, actually if you're subtracting, you bring it to the be positive anyway. So I'm going to bring the x squared to the left to make sure that x squared is positive. And then factor that. Now, most times, if we gave you a quadratic where you couldn't factor it, then that's kind of tough, right? Because then you're using, that means it's a quadratic formula, and then, which would be fine, except then you have to get the y value. So likely if it was one like that, we'd probably say you could do it like that. That doesn't mean it can't happen. It's not. Now, this has a lot of fractions. You want to check and make sure, maybe I made a mistake. How can you check? You can do it by graphing, right? So go to y equals, clear off your anything that's in there. And what do we have here? X squared plus 2x plus 4. So x squared plus 2x plus 4. Now this, I'm doing left side and right side separately, but then we can also check to get the x values by bringing it all to one side. So just give me a sec to enter these. If you do bring everything to one side to check to get your x values, just remember that that's not going to give you the y values. But now, if I do my intersection here, so second trace intersect, enter, 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 I get negative 1.3 repeating, which is negative 4/3, and 3, so that's 3 1/9, which is 3.1 repeating. If you're not sure, remember what you can do. So quit out of this. If I want to check that y value, because I'm not sure, then for y, look for it, it's green on my calculator. So that's alpha 1. If I enter on that, it copies the y value that my cursor was last at onto my screen. Then if I go 28 divided by 9, I can check. Okay. Then, so I got that point right, and then second trace intersect for the other one. I need to go closer to that other one, because otherwise it'll keep giving you the same one every time. Enter, 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 negative 2, 4. Okay, so I've just confirmed that I did the algebra correctly. Okay. Okay, so the questions for these are in your package. Okay, right after this. That is your, so it's immediately following. The answers are there. So this lesson is the last lesson that will be on your unit quiz on Wednesday. Okay, we'll work ahead today. So Monday we'll do Tuesday's work, and then Tuesday you'll have a review period, time to review in class. I think Mr. Vitalik has posted the review practice test in Schoology, or if he hasn't, he will be doing it this afternoon.